Okay, let's develop the event-driven handle simulation in this time. So last time I briefly mentioned about how we can develop the event-driven handle simulation, particularly using sample path analysis. But in this time, I will leave the previous material and then we will develop the event-driven handle simulation together. Okay. Okay, let's understand the nomenclature using the clutter of the symbols using the event-driven hand simulation here. So we have five major columns, and right-hand side, the last one is an event calendar showing you the what kind of event will be happen in future, okay, in the simulation model. And first one just finished the event. So first, ESHAM means is entity ID, such as the event number, okay, and then time is event time, and type is event type. And as you know, we have four major event type in the discrete event simulation, such as initialization, arrival event, departure event, and the end event, right? Also, we have variables. In this example, we only have two variables. And first one is a QT, which is number of entity in the number of entities in the queue, okay? And then BT is the number of BG server, okay? And also we will consider, and you can consider the attribute of an entity in the queue as well as in the server. And here our attribute has a arrival time of an each entity at the system, okay? Last one, you can consider the time persist statistics as well as tally statistics, but in this example, yes, we only have two tally statistics. And WQT is sum of the queue times that have been observed so far, and then last one is the sum of total time in the system that have been observed so far, okay, TS. All right, so this is a major definition of the symbol, and this is definition of major symbols using the event-driven hand simulation. Let me skip this one because last time I already mentioned it. Okay, so let's review this hand simulation. Okay, and in this case, we have two more, actually, the time persistence statistics, as you can see here, and we have a integral of the QT and the integral of the BT, right? So these two are time persistence statistics, and last one is a still tally statistic, which is updated when we have a departure event, right? All right, so initialization event at time 0, the QT value will be 0 and BT value will be 0. Other statistics will be 0, right? And according to the event calendar, we will have a arrival event of the entity 1 at time 0, right? So event number here is 1 at time 0, and event type will be arrival. And as you know, there is no entity in the queue and in the server, right? So this entity can directly go to the server, right? So BT value will be 1 and QT value will be 0. And as you know, arrival time of this entity 1 in the server is 0. So each attribute value will be 0, right? Arrival time of this entity at the system. And then statistical accumulator will be 0 as well, right? At time 0, because nothing happened actually so far. And next one, we have a next event for the entities 2, right? And then it will happen at 1.73, and so another arrival event at 1.73. Yes, so next entity enters the system at 1.73. Of course, it is a arrival event, and entity number is 2. And since the first entity is already in the server, so this entity will reserve the queue, will be sent to the queue, right? So QT value will be 1 and BT value still 1, right? And arrival time of this entity is 1.73. So attribute, each attribute will be what? 1.73, right? All over time. And this is still same because entity 1 is still in the server, right? And next to two values will be like this. Why? Because Qt value this value just became 1, right? So still so far it is 0, right? 1 times 0 is 0, right? As you can see. And then 1 times this value became 1 at time 0, right? And then it's been a 1 for 1.73. So 1 times 1.73 will give you 1.73. Got it? Yes. And then since there is no departure event, your tally statistic will be 0, right? So time persistence statistics, they are actually always updated whenever you have an event. However, tally statistic is only updated when we have a departure event. So that's a difference, okay? Okay, let's look at the next event. Next event is a departure event. Happened at 2.9, right? So part 1 leaves the system at 2.9, right? That's a departure event. And as you can see, once part 1 leaves the system, and next entity in the queue will and can resolve the server, right? So this value, Qt value, becomes 0, right? From the 1 to 0, and then this value is still 1, right? Because the entity 2 is in the server, right? So attributes still the same. So nothing here, nothing in the queue, right? So it's a nothing, and then 1.73 will be the value of the attribute value for the second entity, right? Which is in the server right now. And Qt value will be 1.17 because if you subtract 1.73 from the 2.9, and then it's a 1.17, right? And then times the value can be multiplied by 1, right? So that the queuing time will be total waiting time in the queue will be 1.17. Got it? And then next, this value will be 2.9, as you can see, right? Because it's been a 1 actually from 0 to 2.9, so it's 2.9. So that's why in order to get the right Qt and integration of the Qt and BTM, basically you need to have a correct values for values of these two variables. All right. And then tally statistics. So now we have departure event, and now you need to update the tally statistic here, total service and total service time, right? And as you know, time in the system of the entity 1 is 2.9, right? No waiting time, and then 2.9 as a service time. So summation between these two, 0 plus 2.9 will give you 2.9, right? So the value will be 2.9. Yes. All right. So next we have another event. Okay, another event for the entity 3, and it happens at 3.08. So as you can see, it's a level event, and as you know, there is one entity in the server, so Qt value becomes 1 again, right? And as you know, this value is what? 3.08, right? Attribute of what? Entity 3, right? Which is in the queue. And this value is 1.73, right? Because second entity is arrival time of the second entity is what? Is a 1.73, right? And it is still in the queue in the server, so that's why, right? And then Qt value, as you can see, because we have another event right here, so you need to update the time persistence statistics, right? These two. So this value will be what? This value will be 1.17. Still same, right? Because because Qt value is, although Qt value is 1, but it's been 1 for 0 times. So 1 times 0 is 0. So if you add a 0 to this 1.17, and definitely you will get the 1.17, right? Yes. And then this value will be 3.808, right? Because this value, as you can see, it was always the server, is always busy, right? From beginning to 3.08 minutes. So this value will be 3.808. Okay, and tally statistic is slightly different, right? There is no departure event, so you will have a exact same value here, right? 2.90. Good. And so on. And if you have another event, then you can update the entire table one by one, right? So please consider this procedure to update the statistical accumulator basically, and then update these values here. And we will solve the example actually to understand the logic of the discrete event simulation. All right. Okay, let's look at this practice problem. So let me briefly explain the problem for you. So we have only one problem in this practice, and then the in problem actually parts arrive at the facility for processing in every 2 minutes. The first arrival is at time 1, okay, not a 0, and then these these arriving parts wait in the queue, okay, and first come first serve queue until one of 3 machines is available to process them. So we have 3 machines. Unlike the previous example, we have a capacity of 3, okay, and all 3 machines are identical, so that they spend the same amount of time, okay, and 6.5 minutes. So constant, they just spend the constant time, okay, to process each part. And complete part exit the system, and let's assume that you need to run the simulation for 14.5 minutes, okay, not 20 minutes. So please construct a sample path table shown in this sample path table. Okay, let me give you the time for you, so please complete this table by yourself. And we have one time personal statistic, which is BT, yes, BT value, and then 2 tally statistics, okay, and we have variable. Good thing is that you don't have to worry about the attribute in this example. Yes, please update these cells, okay, in the table. Okay, let's solve this problem together. Hopefully you already solved the entire one. Complete the entire uh, complete the entire table, I guess. Okay, so there is the first event, which is a library event, and at time 1, as you know. So first entity enter the system at time 1, right? So BT value becomes 1, right? Because there is no entities in the server. So server has a 3 has a capacity of 3, right? And TS tally statistics, you don't need to update the tally statistic because we don't have departure event so far. And then BT value will be 0, right? 1 times 0 will be 0, right? So BT integration of BT will be 0. Good. And then Qt value at time 3, there will be second entities or library, right? So however, the Qt value is still 0. Why? Because we have 3 machines, right? 3 servers. So and then this value becomes 2, right? And WQ, TS, they are 0 because so far we have a library event. And BT value is what? 1 times 2, right? 1 times 2 give you 2, right? So that's why this value will be 2. Yes, let's look at the third event or library event here. We have another library event here. So BT value becomes 3, WQ, TS, and BT value will be what? Basically 4 plus, right? So 4 plus because first entity actually resolved the server for 4 minutes and second entity resolved the server for 2 minutes. So 4 plus 2 will give you 6, right? So that's why it's a 6. You can just type 6 here. And next one. So now Qt value becomes 1, right? Because we have only 3 servers. So that's why. And this is still 3, right? And WQ is 0, TS 0, and BT value is what? 6 plus, right? So first entity spent 6 minutes at the server, right? And second entity spent how much? 4 minutes at the server. And last entity spent what? 2 minutes at the server. So if you add all the number, you will get 12, right? So let me just, okay. So yeah. All right. So and then now we finally have a departure event, and as you know, this value becomes 0. However, BT value is still 3 because when first entity leaves the system, fourth entity can reserve the server, right? Available server. So that's why. And Qt, actually now you need to update the tally statistics, right? We have 2 tally statistics. The waiting time of the first entity was 0, so that's why it's 0. However, time in the server, time in the system of the first entity is what? 6.5, right? Right? So 7.5 minus 1 will give you 6.5, right? And BT, yes, I know it's getting very complicated. So 6.5 plus what? So for the first entity spent 6.5 minutes, right? And then now second entity spent what? 4.5 minutes, right? And then third entity spent how much? 2.5, right? So if you add all the numbers, and you will get 13.5, right? You will get 13.5 minute. So let me just remove these equations. Okay, so 13.5, right? So now you have new values. And next, another level. Yes, 3 and right. So another level of the entity 5 at 9 minutes. And here is a 0 still, right? No departure event so far. That's why. And then this TS is still same, right? Because there is no departure event here so far. And then yeah, we only have arrival event here, so that's why. Okay, so and then 9 minutes, at 9 minutes you need to calculate the older number again, right? So if you subtract 1 from the 9, and then you can calculate actually the area. So 8 plus and then 6, right? 8 plus 6, and then this value becomes 3 at 5, so it should be in 3 for 4 minutes, so 4, right? Yes. So you can have actually there is another way. I mean, if you don't like this, this is 18, but if you don't like this, and then you can just accumulate this number, BT number. So start from the 13.5, and then 3 times what? 3 times 1.5 will give you the number, right? So anyway, it's still 18. So there are several ways to calculate the number. So anyway, you will get the 18 as a value of the integration of BT, okay? And there's another departure event at 9.5. Yes, so QT value becomes 0. However, this value is still 3. And now you need to update the tally statistic, right? Because we have departure event, right? Second departure event. However, as you know, queuing time for the second event was 0, right? And however, and time in the server, time in the system of the second entity is 6.5, right? So you can add another 6.5 from the previous 6.5. So you will get what? 13, right? Okay. And what about BT? BT value? Yes, let's add another number here. So 0.5 times 3, right? So 1.5, you will get the 1.5. So this will be 90.5, right? And 11, at 11, another arrival. So this QT value is 1, and we have 3 in the server, 3 entities in the server so far. And then WQT and TS is still same because this is just a arrival event. And now you need to update this number, and 9.5 plus what? 1.5 times 3, right? 4.5. So 24, right? Will be the value. Next, we have a departure event of third entity, and as you know, this one also does not have a waiting time, so that's why you can have still have a 0 total waiting time, and QT value is 0 because this entity, when this entity leaves, and entity 6 can reserve the server. That's why. Okay, and TS 6 point, 30 point, and also this one spend the 6.5, right? So if you add the 13 plus 6.5, and then you will get 19.5. Okay, so which is the total time in the system, right, of the 3 entities so far. And then this one, 24 plus what? 0.5 times 3, right, will give you 25.5. So you will have a 25.5 here. All right. And 7, another arrival event for the entity 7. Here we have actually part 7. Yes. And so that's why this value will be 1 and 3, right? And this is a arrival event, so you don't have to worry about tally statistics. And last one is a time persistence statistic, right? So 25.5 plus what? 1.5 times 3, right? Because if you subtract this value from this value from here, and then definitely you will get 1.5, right? And then time 3, because capacity BT value is 3, so it will give you 4.5, right? This will give you 4.5, so you will get 30 here, right? Yes. Okay, so this is a departure event entity 4, and as you know, there was a waiting time for the entity 4, which is 0.5, right? So here, if you check it, entity 4 was spent 0.5 in the queue, right? So, and this is departure dependent, so that this value qt becomes 0, vt becomes 3, right? Because the entity 7 enters sees one of the server, and here, right, 90.5 plus 1, so time in the system of the entity 4, right, will be is a 7, right, 7 minutes, so you have to add a 7 to the 19.5, so which will 26.5 will be the value of this total time in the system. All right, and then here, so 30 plus what? 1 times 3 will be 3 minutes, so 33 will be the value. And 0, this is at the end, nothing happened, so you can have this value. And also 3.5, 34.5 will be the value, so you have to update this part at the end.